Previously, we looked at an example of a limit that failed to exist because of unbounded behavior. This time, let's consider the function y is equal to sine of 1 over x as x approaches 0. This is a classic example of an oscillating behavior. The graph looks something like this. As x approaches 0 from either side, the function oscillates more frequently between 1 and -1. And that's because as x gets smaller, 1 over x gets bigger. So the y values go between all real numbers between 1 and -1. And it does that an infinite number of times and never settles at a single number. Therefore, the limit as x approaches 0 of sine 1 over x does not exist. At this point, I want to share that all the examples used in these lessons came from the illustrative examples from the AP course and exam description. And because this objective is pretty specific, and the example we're using in this lesson is a good example of this, I want to point this out. When you're using your graphing calculators to investigate the behavior of functions, such as sine 1 over x, at a certain point, like x near 0, you can't always trust your graphing calculator because they have physical limitations. Your calculator will most likely give you an incorrect graph, and that's because there's an infinite number of oscillations over any interval that contains 0. So let's recap the common types of behaviors associated with non-existent limits. The first one we covered is when left-hand limits are different from the right-hand limits. And these are also known as one-sided limits. The second type of limit that failed to exist is when f of x is unbounded, such as the function y is equal to 1 over x. And finally, the one we looked at in this lesson is when f of x oscillates between two fixed values as x approaches c. It fails to settle at any single value. There are other functions that have unusual limit behaviors, but these are the three described in the AP course and exam description. Now, on that note, I want to remind you that we gave you an informal definition of a limit, which is the limit as x approaches c of f of x is L. This is informal because there's no exact meaning to the phrase x approaches c or f of x gets arbitrarily close to L. Limits are more formally described by the epsilon delta definition of limit, but this is not assessed on the AP exam, so we're not going to cover it in this course. But if you want to check it out, it's called the epsilon delta definition of a limit.